Today I'm going to show you how to use the node Raycast in Geometry nodes, and we'll show you some examples to understand better how it works. So let's see. Let's take the camera, the light, go to Geometry nodes. Let's hide this panel, this one, and this one. Let's get a new profile, lock this panel, and let's use a grid. Let's connect it here, make it bigger, and add more vertices. Now let's use another object, for example mesh, monkey. And let's bring this info here, object info, and let's select this SUSA. Really important, select relative, because we are going to move this object and we need the real-time location. So let's press G, Z, and leave it here, for example. Okay, so we have these two objects, and now let's move this here and this here. And let's bring the start of this tutorial, Raycast node. As you can see, this node is not really friendly. As you can see, it has a lot of inputs and outputs and a lot of information in the middle. So be patient and give me some time to explain you the best I can. I promise you, this is one of the most complicated tutorials I did until now. So let's see how it works. This node, it's called Raycast. And basically, it casts rays. That's what it does. Now, it needs a target. Think like it's a shooter and it's something to shoot. So now we are going to use the SUSA. Connect it here, the target. So this, let's add some nodes, it's the rays. Really important, because this is really confusing, trust me. And this is the object being hit by the rays. So is the target of this. Now, we have the rays, we have the object that is going to be hit, but we need something to cast these rays. So the geometry that we are going to use with any of these outputs will be the caster, the shooter. In this scenario will be this one. So let's call this one caster. So we have a caster, the rays, and the target. However, this is not casting rays because it's not connected. So let's come back here. By the way, let's give some colors here. For example, let's press N with the frame and go to node, select color, and let's select, for example, this color, yellow. And this will be red because it's our target. And this will be the caster, the shooter. Let's select blue. Now, one of the most important outputs of this node is this one, is hit. So this is a Boolean. A Boolean is like a selection. It says true or false. So this is going to shoot a lot of rays. And it's going to shoot to this. And it will tell you which rays is going to hit this object. So for example, as you can see that this is a Boolean, we can use it, for example, delete geometry. If I add delete geometry to this grid, it's going to delete the geometry. Obvious, right? I know. And here we have a selection. A selection is a Boolean. Remember, Boolean is to say true or false. So it's to filter which part we want to apply a node. In this case, deleting geometry. So we can use this information, a Boolean, with any selection. So let's try. And now, okay, nothing happens. So that means that the rays is not hitting this object. But now this is the caster. This is really important. This is the caster, this is the rays, this is the object to hit. And we don't have anything deleted because it's not hitting the target. So why it's not hitting? Because here we have the direction, the ray direction, and it's -1. So remember, this is the caster and it's shooting rays in negative Z. So negative Z is this direction. So it's shooting a lot of rays in this direction. Something like that. From all the geometry. And it's not hitting anything. However, if we change the direction, so in positive Z will be something like that, right? That means that always in this direction. So if we want this direction, let's select positive Z. And now we have a hole. Why? That's why, remember, this is the caster because now we're using this information. And the caster is casting rays. Remember, Raycast. And it's trying to hit this object. And the direction, we say that now is this one. So every part of this mesh is trying to hit a ray. Every face, every part of this geometry is shooting a ray. And the rays that is hitting the target, remember, the target is this one. The ones that intersect with the target, so it hits, then is this information. If it hits, it's true. If not, it's false. So if it's true, then we can use this information to apply it to a selection. In this scenario, to delete the geometry. So thanks to this, we are saying only delete the geometry that shoots and hits this part, that casts rays and the rays hit the target, because we define the target, the object being hit by rays. So this is how it works. Now, if you want more resolution, when we delete this, you need to add more little shooters. So more little shooters, more parts being deleted. So the shape of the selection is always defined by the resolution of the object that is casting. If we select really few vertices, now it's been deleted only for squares because it's like every square have one shooter. And if they intersect with the target, then they are being deleted. Now there is something important that you have to know, that these rays have a length. So to control the length, we have here the ray length. So now it's 100 meters. To see better this example, I'm going to add some curved lines. You don't have to do this, but it's just to see better these lines. So I'm going to add join geometry and make a copy of this grid and convert it in instance on points. And I'm going to add curved lines. So now we have a line in every point. However, the lines in reality is like in the center of the square. Now what I want is to control the length of these lines. So I'm going to select direction, because here I can control how long is this. So I'm going to match this with the length of the ray. So what we have to do is to create a single value, and let's connect it here. So now I'm using the ray length with this value, and it's the same length that these lines. Now you can see how long these rays are. Okay, let's decrease these rays. Doesn't have to be so long. For example, let's start with 0. And now you will see, let me clean this a bit. Now you can see that the hole disappeared. Why? I'm going to hide the cursor because I don't like it. Because we don't have a ray length. And if we start increasing this, you can see that until this rays doesn't hit this, is not being applied the selection, so deleting the geometry. And we can see that they are still not touching the object. Can you see it? However, if we increase this, in some moment, it's going to delete. So now it's deleting because some of them is touching this geometry. Remember, it's like in the center more or less of one square. So if you want to see better, let's add more vertices, of course. And now you can see better. I'm going to say something like that. And let's come back to the end. Yes, now we can see that anything is touching. And more we increase, there is nothing deleted. And now should start deleting. And we have this shape because the first ones touching is these ones. So more we increase this, more part is being touch being hit, so more part is being delayed. And if we increase everything, then we are saying that almost everything of this zone is being hit. So now you know how this works. And then what we have, remember, is the ray direction. So here I can change the direction, but now these lines is not matching the direction. So if you want to use a little trick to see the direction of the lines, with this example, we can, because here in curved line, we also can change the direction, right? So we could match this with an empty. So let's create an empty. And let's select this position. So let's bring object info and select empty and use the location of the empty to control the direction. So now the curved lines is facing the direction of this empty. So if I move the empty, you can see that the lines are following the direction of this empty. So now let's try to match. Going to decrease the number of lines. Let's try to match the direction of the ray direction with the empty. So the lines will represent the direction of the rays here. So now you can see that with this empty, we are controlling the ray direction. And thanks to this instance that we did, remember, you don't have to do it, we can see better how this works. So let's move this. And now you can see, let's add more vertices. You can see that the rays are going in this direction. So if these rays hit something, then this part is being deleted. And if we make this shorter, then in some point, we start getting back the mesh. Okay, congratulations, you understand how Raycast node works. And this is really important that you understand that this is the object being hit and the caster always is the object that we connect the rays. Now that you understand this, I'm going to delete these lines and use another object as a caster. Okay, so basically what I did is to change the grid for a UV sphere. And add a node here to know that this is the ray length, remember, because it's connected here. And this, the ray direction, is the empty. So I add this node to know that this is the ray direction. It's just a simple setup. And here you can see we have the Susan inside, the sphere, and the empty to control the direction. So now we can see that we have a hole here. Remember, because the direction is now this direction, but now we have a 3D object. We don't have a grid. So it's really important that you understand that the rays come from all the parts of this object. So we have rays here, 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 something like that, but also from this part. So they're facing this direction, right? So every part of the mesh is trying to go to this direction. And we have, let's toggle X-ray. We can see that the ones that are hitting the target is going to be deleted. So these ones. That's why we have a hole here. And if we want to have the hole here, then let's move this object, the empty. So now we are inverting the axis. Because remember, always this is the direction. If you want to see better the direction, what we can do is to add a line and connect it to the center of this empty and to the center of the Susan. So we can see better the ray direction. So let's do it. I'm going to add really fast a curved line with a mesh. And here we have a line that now is in the center, and we have the start that we can move it. Is this part. And then we have the end. That is this part. So I say that I want, for example, the start here, or for example, in the monkey, it doesn't matter. So this part here, and now the other part in the end. So the location of the empty. So now if I move the empty, I can move this line. I'm going to make it thinner, and I'm going to add this here. So now this line, I'm going to increase a bit, is the ray direction. So you know that all the rays, remember, all the rays are facing the position of the empty. You don't have to do this, but it's easier to understand where the hole will be, where the selection. So now seeing this line, we know that the hole is here. And also because we can connect the position of the Susan with the empty line. By the way, I'm going to give some color to every element so it's easier to see it. So I did basically is to give the same color that I have in the frames. The sphere is blue, the ray direction is green, the object being hit is red, and the rays we cannot see them. Okay, now let's see what more we can do. I told you at the beginning that you can apply this to any node that have a selection. You don't have all the time to make a hole. By the way, something important. Now, why it's not working? Because, of course, because the rays are facing this direction. So now this object is not inside, so any ray is touching this object. But if I move this, we will have a hole here. Okay, by the way, I'm going to add more resolution. I'm going to make it bigger, the object. Okay, perfect. So what I was saying, let's delete this. And for example, let's add, I don't know, extrude. So you get an idea what you can do. Now we're extruding all the mesh, but you can apply this to the selection. So now it's only being extrude the part that is being selected. It's being hit. And we can play with this to make this animation if you want. You can scale this more. Also what you can do is to, for example, to move the Susan. I'm going to select here the Susan. And if you bring it to this direction, now this part is hitting this object, but if I want this part to hit the object and extrude it too, then I need to increase the ray length. So now it's longer the rays, and this one can hit this too. So we have this weird effect. And remember, you can scale this. Also, what you can do is to rotate it and do whatever you want. Now let's see another example. We can delete this and look at here. We have a selection. So what we can do is only to apply this material, the blue material in the sphere, where it's being hit. So now we have like a shadow here and the other side. Remember, if you don't want the other side, then you have to do the ray shorter. So this is another technique to do like a shadow. Now maybe you're wondering, and how I use all this information? Hit position, it gives you the position of the hit. Remember, the position when a ray hit. So you can get this position. So how we can use this information? For example, what we can do is to convert this UV sphere in instance on points. We can first of all say only apply instance in the hits. So let's use hit in selection. And now we only have UV spheres where it's getting hit. So you can use this like a scanner if you want. And with these UV spheres, we can change the position with set position. You can disconnect this. And then change the position of these UV spheres, this instance. And say, please, use the position of the hit. And you have to set it here, in position. So right now, what is happening is that all the instance, all the parts of the mesh that were instance, that were hitting this object, its position is changing to the hit position. That's why now you see a lot of UV spheres instance in the position of the object being hit, thanks to hit position. If I disconnect this, then they come back to their position. And then you have hit normal that it gives the normal of the hit position. So that means, remember, the normal, remember, is the arrow perpendicular to a face. And it's more or less one value, 1 meter. So we can say, okay, get this position and offset it. Instead of doing something like this, offset it in the normal of the heat. And now every instant is being offset in the normal of the heat. So for example, to understand it, think like it's bouncing. To say it simple, it's like they come and then they move 1 meter or one value. Maybe you're wondering how I can use this. Honestly, I didn't try too much this node. I'm just trying to teach you how it works. Maybe you can try new setups and try to think ways to use this information. But for example, what you can do at a mix vector, that is to change two vectors, and now we are changing from the position of the heat to the position of the normal. This is the position of the normal, the heat, and this is the position of the heat, because we are using the offset. If we disconnect this, won't work, because we lose the heat position. So it's just an idea, okay? You can do whatever you want. And look that if we move this, it's going to react, remember. And also if we move this, of course. And then I'm going to disconnect this. Then we have also here the heat distance. I don't know how to use this information, honestly. Heat distance is basically a float and tells you the distance between the position of the ray star until it hits something. So this value is this, heat distance. And you can use it with all the geometry that is hitting this target. But honestly, right now, I don't know how to use it. But at least you know how this works. And then, to finish, what is this? Attribute, and source position. This is similar to sampler index and sample nearest surface. If you watch my tutorial, it's the same. So basically, here you select, for example, a type of data. So now we are working with float. That's why this one is gray and gray. But if you select integer, then it's converted to an integer, a vector to vector, color, boolean, etc. So is to get an attribute and get the output when you analyze, for example, from an object that is being analyzed with the Raycast. So where the rays is hitting an object, a target. So you can get information, any attribute of this geometry. But right now, honestly, I don't know how to use this information because I didn't try it. Maybe in the future I will do more tutorials and I will have more ideas. But right now, I don't know. And this is related with that. So you can get, for example, the nearest point or interpolate. That means that, for example, if it's analyzing a face, interpolate means that it's analyzing everything. However, if you select nearest, then, for example, if you use integer, I don't know, whatever, it will take the nearest point position of a geometry. It's only that. And with this, more or less, I think I teach you everything I know about this node. As you can see, it's a long tutorial, maybe the longest I did. It's not easy to do, so I hope you like what I explained you. And now it's your turn to start practicing and see what you can do with this node. Remember, you can change this object. I'm going to get this and add, for example, another UV sphere and select here this UV sphere. And now, if I move this and make it bigger, looks like a scanner. If you want like a real scanner, I'm going to give you another idea before we finish. Let's do like this. And we can add mesh to curve. So we are going to convert this object to a mesh. But everything, no. I'm going only to use where it hits because we have another selection. So let's use is hit here. And now it's only converting the part that is being hit. And what we can do, you know we can do. Convert curve to mesh. So just to give you another idea, what I did is to take the UV sphere, to convert it to mesh, but only the parts that is being hit, and change the material to make it glow. So thanks to this now, I can control this scanner effect. And here we have the empty, so we can make like this animation. And you can use any object to project the rays. So I hope you get some ideas to how to use this. And also what you can do, remember, is to play with the ray length. So, for example, you can do this. Start from one position to another. So I know it was a long video, but I hope you learned something new. And if you like this video, please give a like, subscribe, and you can download this project and many more on my Patreon. And see you in the next video.